When expressing a set of numbers using interval notation, we'll be using parentheses and brackets. Parentheses are used when the element that either starts or stops an interval is not included in the set, and brackets are used when that element is included. A closed interval is one where both endpoints are included. And so if we were to express this in interval notation, we'd open an interval using a bracket because the value a that begins the interval is included, and then we use a comma and then write the value that ends the interval, also being wrapped up with a bracket because, again, that value is included in the interval. X can be equal to b and it can be equal to a, and this is why we use the brackets. But if x is not allowed to be equal to a or not allowed to be equal to b, this would be called an open interval. Then we would use parentheses to open the interval notation, starting with a, comma, going all the way up to b, and then we would use a parenthesis around the b, also indicating that b is not included. Another way to represent an infinite set is by using set builder notation. When we're trying to express the set of all real numbers in between a and b, where x can be equal to b but is not equal to a, the set builder notation has a particular template. We open up the set using curly brackets, and we say the set of. Then we write down the x, and now what it says is the set of all x's. The next thing in set builder notation is a vertical bar, and this vertical bar represents the phrase such that. So now it says the set of all x's such that. After this bar, we leave a space for what we'll call the criteria. And this is where we'll place the inequality itself, and then we'll close the set. So when using set builder notation, this is a template that we can use. For this particular case, let's go ahead and lay in our criteria. X is strictly greater than a, but also less than or equal to b, and this would be the set builder notation for this particular set. Let's look at a couple of examples and express these sets both in interval notation and in set builder notation. We'll start by graphing each set on a number line. And on my number line, I'm simply going to plot a couple of points of interest. When we're graphing the set of all x's that are less than or equal to 4, that means we're going to start at the 4 and shade to the left on the number line. If the x's are allowed to be equal to 4, that means that the 4 is included, and if the 4 is included, we're going to use a bracket notation to indicate that inclusion. Expressing this interval in interval notation, the interval notation is always going to start with the smallest element in the set, and then we have a comma, and it finishes with the biggest element in the set. And we either have a parenthesis around that or a bracket, depending on whether or not that element is included. In this case, the smallest element in the set is negative infinity. It goes down and down forever. And the largest element in the set is positive 4. So our interval notation is going to start with negative infinity and finish with positive 4. And infinities are never included. We always get a parenthesis around an infinity. And again, we see that we have a bracket around the 4 because that 4 is included in the set. So this is the interval notation for part A. The set builder notation, again, starts with the template where we open up a curly bracket which says the set of all x's, vertical bar means such that, and then we have a criteria field in here. And this is the area where we can place our original inequality. This original inequality is the criteria that is to be met, so it goes in right here. So our set builder notation reads, the set of all x's such that x is less than or equal to 4, close set. And this is set builder notation. Let's do this again for part B and C. We'll start with the number line, and I'm just going to plot a few points of interest on the number line, not many. Let's begin by shading the region that satisfies this inequality. So the smallest element is negative 1, but the negative 1 is not included, so that's going to get a parenthesis. We want all the x values that are bigger than negative 1, but also less than or equal to 5. So we stop at the 5 and include the 5. So this is the region of x values that are both at the same time greater than negative 1, but also less than or equal to 5. Notice when we express this inequality in interval notation, the interval notation is going to look very similar to what the graph looks like on the number line. We're going to begin with a parenthesis and the smallest element in the set, which is negative 1. We follow that with a comma, and then the largest element of this set with the bracket this time because that 5 is included in the set because we have that or equals to symbol there. And so this is the interval notation representing our set. Now in order to write it in set builder notation, We begin with the same template every time. The set of all x's such that some criteria is met, close the set. And what we put into the criteria field is the original inequality. So that comes down around here, and we'll have -1 less than x less than or equal to 5. And this is our infinite set expressed in set builder notation. One more time here for part C. First, we'll graph it on the number line, plotting just a few points of interest. Our inequality says that we want the x's that are less than 10, but not including the 10. So we're going to begin at the 10 with a parenthesis because 10 is not included. And then we're going to shade all the values that are less than 10, which is to the left, and all the way down to -infinity. In interval notation, we begin with the smallest element in the set, and in this case that's -infinity, but we never include infinity, so we're going to have a parenthesis there. Then we write down a comma, and then the largest element in the set is +10. That element also gets a parenthesis because 10 is not included in the set. X is not allowed to be equal to 10. So this is our set in interval notation. In set builder notation, we start with our template, the set of all x's such that some criteria is met, and the criteria that is to be met is that x is less than 10. Again, this is just the original inequality in that criteria field, and this is the set builder notation for part C.